IP tools. In this nugget, we take a look at TCP/IP tools, and specifically with ipconfig, which you might have used in the past, but which also has some new options that are very useful for us in the present. One of the things that it can do is to clear out name caching, or to show you any name caching for DNS addresses that it has. And you can also use other tools to look at the MAC addressing and any MAC addresses that have been cached. So we'll take a look at some of those things. We'll also take a look at how to repair a connection using a simple button, and it does a whole bunch of things at once to fix that connection, as well as automatic private IP addressing, which is an address that you'll get in absence of a DHCP server. Now, in absence of a DHCP server, you might also just want to opt to get a static IP address, and that's what the alternate configuration is. You need to know certain key ports that are commonly used ports for various types of services in TCP/IP, and we'll also take a look at several other tools that don't really fit on here, things like traceroute and netstat, pathping, netdiag, and more. Now, when we looked at all the TCP/IP configuration properties, those are all just various radio buttons and checkboxes that are various pieces out of the junk drawer where you could troubleshoot something to make sure that something's configured properly. And there's also other things you can use, such as various command line utilities that are also pieces that appear in the junk drawer there. We could go to our command prompt, for example, and use a very common tool called ipconfig. We've been using this for years in Windows NT-based operating systems. In legacy operating systems like Windows 95 or 98, you'll use WinIPconfig as its equivalent. Now, here we just get rudimentary information. I think that pretty well explains itself about ipconfig. You can also use a / question mark if you want to use all of the available command or view all of the available switches that are available there. In our case, I'm just going to show you the most prevalent ones that you'll need to be able to use. So I'll go ahead and clear the screen here and show you ipconfig, for example, / all. This gives you the most complete information that you can get out of ipconfig. And this identifies things such as the host name, the primary DNS suffix, which you saw earlier in the system properties. We can change to something else if we want. We also see the DNS suffix search list. So it's going to match the primary DNS suffix by default. We could have also added in their additional connection-specific DNS suffix, remember, like cbtnuggets.com, which I've cleared in this case. And then in that case, that would also add DNS suffix search list for nuggetlab.com and cbtnuggets.com. Other key information here is the physical address, which is also known as the MAC address, which is the Media Access Control. I don't know why they call it that, but that's another way of talking about it. The physical address, the MAC address, whatever you want to call it, that is a unique hex identifier that's burned onto each network interface card. And the first part of this references whoever the manufacturer is. For example, Intel uses these first hex values. And then the remainder of this will be identifiers that are unique to Intel hardware. Also shows you whether or not it's DHCP enabled. If it were to say yes here, then it would also identify another line in here, which we don't see right now, which is the identifier or the IP address for the DHCP server. We see the other self-explanatory items down here as well. Now offline here, I went ahead and made the IP properties of this connection DHCP enabled again. And when I say offline, that means I paused recording, went behind your back and did something, and then came back. So that's what that means, and I just did that to save time. But let me show you what I did here. Like I said, made them DHCP enabled, this client. So now it's a DHCP client. That's why this says yes, and it's going to receive an IP address from this DHCP server. The configuration would include any Win servers if I had any. I don't have any, so it doesn't matter for that point. Any DNS servers that are configured, any default gateways, that'll all be configured in my DHCP server. And in fact, let me just go ahead and show that to you, and we'll talk about this more later on. Here, I've got a scope of 10.10.10.0 in my Nugget Lab scope, which I've configured. My scope options are I'm going to use as a router 10.10.10.1, as a DNS server 10.10.10.20, and I can add more in there as well if I would like. Now that just gives you kind of an overview or a briefing of DHCP here. And again, a lot more detail coming up on that. Now, the reason why I'm bringing up DHCP here is because it does relate to the ipconfig tool. For example, what if I changed my DNS server? Well, you see here that I obtained this lease on February 18th at 12-something p.m. It's going to expire 8 days later. Is that right? Yeah, 8 days later. And that's the default duration. Well, if I change this DNS server for all of my clients, this one blew up or something, and now we got another one that's going to have a different IP address, then these clients will continue to access a DNS server that no longer exists, and they're not going to be able to resolve any names. So if I know that's the case, then I could go to this server where I've already changed the DNS servers in my DHCP options, and I could go ipconfig, and then I could do a renew IP. And what that would do then is it would both renew the lease for my IP address as well as all of the configuration information that I had. So I typed in renew there and pressed enter. And now when I do an IP config all, we see that it has indeed picked up this new DNS server that I had out there, in which I changed on my DHCP server's scope options. Just so you're aware of it, in the past, for example in NT, Windows NT 4, in order to get any new options, you would have to first do an IP config release, and then you would do an IP config renew. And that's exactly what I typed in here, just for a drill, if anything else. I released the address where we wound up with no IP address whatsoever, and then I did an IP config renew, and it brought it back all to us. Again, that's only in Legacy NT that you'd need to do that. Now, another very useful part of IP config relates to DNS name resolution. For example, if I want to see who I've been able to resolve in the past, which hosts I've been able to resolve in fully qualified domain names in the past, I can do an IP config / display DNS. And this shows me what it's been able to resolve. Right now I see that it's only resolving its own loopback address, which you can see in which we discussed in our previous nugget. So let me try that again. After I ping something, let's try pinging ping DC nugget 1. How about that? Now after I ping that, then we see that it's resolved that to this fully qualified domain name, so that if I display DNS again, then notice that this time it does show me DC nugget 1 is 10.10.10.20, and it gives me the fully qualified domain name here. So that's interesting and useful to be able to resolve that and to be able to see what we can resolve using IP config. Another useful purpose of IP config is also so that you can clear the cache. So for example, if I were to ping a host that for some reason was unavailable, client 02 for example, it does not have a host record in DNS. So when I try to ping client 02 either flatly or if I do, NuggetLab.com, doesn't matter. If I try to ping it, it's going to say, can't find it. Well, since DNS was not able to find it, it sent back a negative query. It said it was not able to find client02.nuggetlab.com. This local machine where I performed the ping will cache that in memory, and then if I try to ping client02 again, it won't even ask DNS this time. It'll give me the same answer, but it doesn't even ask DNS the second time because it says, hey, I already asked DNS. DNS already doesn't know what the answer is. Therefore, I'm not even going to try to look it up again. Well, later on, if I do bring up client 02, it does get an IP address, it does register a host record, so now it would be available to me. Then any other clients that are on the network that try to ping it for the first time after it comes alive, they'll be able to get a reply, but oddly, this computer won't. And that'll be a little bit baffling at times because it'll say, some clients can get it, some clients can't. All my other networking here is working fine. Why can't I access client 02? Well, it's because it's cached, done that negative caching. So in order to fix that, you do an IP config clear cache. Flush DNS. And then that would clear out the DNS resolver cache. Then when you pinged client 02 again, it would again, this time go directly to your DNS server where it now has an A record. Then it would resolve it and you'd be back in business. Now here I can also ping client 01 where I'm going to get successful responses back, and that looks like fine. Okay, why are we concerned about this? Well, we're not immediately. But if we have to change the IP address on client 01 for some reason, this client where I've performed the initial ping still has cached in its memory 10.10.10.45. And if the new IP address is actually 10.10.10.23 on client 01, then this client will not be able to successfully access that particular client because it's resolved that in cache. Therefore, it says, since I already know what the answer is, I'm not going to bother the DNS server, even if the DNS server has a properly updated host record. And in fact, here I quickly flip back over to my DNS server where I have client 01 on 10.10.10.23. However, like I said, this client here, this client that's trying to ping client 01, when it does so, it still remembers the old one, not accessing DNS. Therefore, that would be another good useful purpose for ipconfig flush DNS. This time when I try to ping client 01, then, since it doesn't have it in memory, it'll do a fresh query to the DNS server, gets the right answer, gets the right replies, and we're back in business again. Now also, if I am that client 01, and perhaps someone manually changed my IP address on that client, then I might still have a stale or an old host record in DNS that no longer reflects my actual correct IP address. And if I want to make sure that it gets updated, and if it does support dynamic updates on DNS, then I would do an IP config again here, and if I can type IP config, and then I would do register DNS, and that would give a fresh registration to my DNS record. Now, when I ping another host, or I can ping by IP address as well, by the way, where it doesn't have to use DNS to resolve a name. But regardless of whether I ping to an IP address or ping to a host name or anything else, when I access another host on the network, it initially resolves to an IP address so that the IP address that's assigned to that network card can communicate with that network card. But that still isn't the lowest level. What has to happen yet is it has to get to the physical level so that it can access it by MAC address. And in order to do that, it uses something called Address Resolution Protocol, or ARP. And if you need to know what the MAC address is of a remote host, you can just do ARP-A, for example, and that will show you what it's been able to resolve remotely. It was able to resolve 10.10.10.23, which was client 01, to this physical MAC address. And this is handy sometimes because you do need to know that MAC address at times, or that physical address, in order to do things such as a DHCP reservation, so that you can guarantee that this particular MAC address always receives a specific IP address. And we'll talk about that more when we look at DHCP. Now, in terms of troubleshooting with ARP, there's not really a whole lot there in my opinion. And some people may disagree with me, but I don't really think you're going to see a whole lot here in terms of troubleshooting, because you see, the ARP cache, and that's what this is a visual display of the ARP cache, has a timeout of about 2 minutes. So I'm not going to run into any situations in troubleshooting where suddenly this MAC address changes compared to this IP address that it's associated with. I mean, someone shuts down that computer, replaces the network card, starts the computer back up again, and they give it the same IP address. Well, now it's got a new MAC address, but it's got the same IP address, and that's not really going to be an issue because we're not going to be able to do all of that work anyway within 2 minutes. And after 2 minutes, when it clears out of the ARP cache, then we're going to have to resolve the IP address to the MAC address fresh anyway, and it's not really going to be an issue in terms of ARP. However, if you absolutely had to clear the ARP cache, you could do ARP-D for deleting or clearing the cache, and then you could specify an asterisk, which would clear all of the ARP cache, and then now when we did an ARP-A again, it would only show us our mapping to our local host right here, which is always going to be there, and of course you see that that's dynamic. By the way, these all show up as dynamic. You can also do an ARP-S, and that would allow you to enter in a statically assigned IP address with a statically assigned MAC address if you needed to. In addition to DNS resolution, you can also do things like by flat names or NetBIOS names, which will often have to happen or have to be resolved using broadcast, especially if you don't have Win servers. So, for example, even on this local segment where I currently am, I have a server named .net, which is in a different domain, and it doesn't have a host record in any of the DNS servers that I'm using. So if I ping to that host, ping.net, then it's able to resolve it. Notice it doesn't give me the fully qualified domain name because I don't have an A record or any other kind of a DNS record for it. But as a result of broadcasting, it's able to get an answer back. Now, if I do an NBT stat, then I can do an NBT stat dash R, and as you see the resulting output down here, it's able to resolve it by broadcast, and there it is, .net, so I was able to resolve that name by broadcast. If I had a Win server, by the way, it would also show me any resolved names by name server, and that's not a DNS server, that's only a Win server. I don't have one, so it doesn't show me anything. And also notice that NBT stat uses case-sensitive options there, so the lowercase -r does just what I showed you. It shows you what's been resolved. If I did the same thing only with an uppercase R, that would then purge and reload the remote cache name table. Likewise, if I did a RR, what that would then do is it would send name release packets to a Win server if I had one, and then it would go ahead and refresh the name cache. Now, here are several of the things that we've used from a command line today. ipconfig with the renew, the ARP command, NBT stat, and a couple of different implementations there. Another couple of ipconfig things, all of which I've shown you from the command line interface. Now, if you're having trouble with IP and you're trying to troubleshoot it, a lot of times it's going to relate to name resolution, whether it's NetBIOS names or DNS names and all that kind of stuff. And that's what these things often will take care of, clear down to the hardware MAC address using ARP here, for example. Now, as a human, I might try to troubleshoot and try to remember to type in all of this, or I might type something in wrong and all that. Well, it's really much easier if you have something do this for you all automatically now. And in fact, we do, starting with Windows XP. Yes, if I go to Control Panel and go to Network Connections, and then just open up one of my network connections, go to the Support tab, you see this Repair button here? As soon as I click it, it gives you kind of a generic message there, just saying that it's trying to repair a problem, and if you still have a problem, contact your ISP. Thank you very much. But what it really does here is all of these commands for me automatically, and it really helps to remove the human element, and it's kind of a shotgun blast of a lot of common troubleshooting troubleshooting solutions for you. Now let's take a look at another troubleshooting scenario where I have a server here that is able to communicate with this server over here, and it's up and running. But this server over here that is also up and running, it can't communicate with for some reason. This desktop client up here, it's able to communicate with that desktop client, but this desktop client over here, and these are supposed to be desktops, by the way, it can't communicate with that one. What's more, it cannot communicate at all on the internet, and it cannot communicate at all with any other subnets that are going on. Well, what is this telling you? What I would do if I was looking at a situation like this is I would immediately go to ipconfig. And indeed, if I do go to a command prompt and type ipconfig here, then I see that I've got an IP address of 169.254. And this Class B address is set aside by the Internet Assigned Numbering Authority, or IANA, as a Class B address that's used for assigning an IP address to a client that is configured to use DHCP, and yet it cannot locate and obtain an IP address from the DHCP server. Well, what's the advantage of doing this? Because you see, this IP address range, this whole Class B range, is not routable on the internet, so I can't communicate on the internet. But what it does is, at least it gives me some modicum of communication. What's happening in this scenario is, this client computer here did get an IP on a PIPA address. Also, this client here, when it was trying to renew its IP address, it also got a PIPA. This one also got a PIPA. Therefore, since they're all on 169.254, they can all communicate with one another. But since it's not routable on the internet, they can't communicate on the internet. And since you're not going to configure your routers with a non-routable IP address, or a PIPA address, if you're smart anyway, then you're not going to be able to communicate through the router to some other networks over here either. And that's why we're able to communicate with some of these servers and clients, but not others, because these have got an PIPA addresses. These still have their actual working IP addresses, and they haven't tried to renew against a DHCP server yet. So basically what that tells you is anytime you see an IP address of 169.254.x.x, then you know immediately that this is an PIPA address and that you have a DHCP server down or unavailable. Now, the other advantage of using a PIPA addresses for your clients here is that if the DHCP server does come back up online again, then periodically these PIPA clients right here, they will try to refresh or try to renew a DHCP address every 3 minutes. And therefore, once that DHCP server comes back up again, then they'll say, oh, there you are, and then they'll get an IP address from that DHCP server. Without using a PIPA here, what would have to happen then is they would just not get an IP address at all, and then once the DHCP server came back online, all of these clients here would have to be rebooted in order to be able to get an IP address, and that might not be desirable. Now returning to the TCP/IP properties on my network interface card here, again notice that I have obtained an IP address and DNS server automatically, so I'm using DHCP again, which is what that means. And notice that as long as I've got this radio button selected, I also have a tab here that says alternate configuration. If I had a static address in use, then that tab disappears. What's this tab about? This means that if I'm unable to get an IP address and I don't want to use a PIPA, then I could choose an alternate configuration instead, which would be something an administrator has to put this in, by the way. Users can't do this. And this also applies to XP computers. Then I could put in another IP address and say, hey, just in case of an emergency, my DHCP server's not up and running, I still want this server to be available on the network and not to come up with a 169.254 address. So we'll give it 10.10.10.80 if the DHCP server's ever down. We'll give it 255.255.255, and we'll enter in the default gateway that we want and the DNS server and all of that kind of stuff. And then that way, if we can't get an IP address instead of getting 169.254, we will get this instead. Now, for your XP clients, that's more useful if they have an IP address that they're required to use in their ISP when they go home. They take their laptop home, but when they come into the corporation, into your network, then they have to use a DHCP address. That would be useful for flipping back and forth between a static address at home and a DHCP address at work. Now then I also have to point out that it's extremely unlikely that you'll use DHCP for any servers, because as I discussed earlier in our series here, you don't use DHCP very often for servers at all. I can't really think of any good reasons to do that, because you want them to usually use static IP addresses. Nevertheless, a PIPA needs to be something that you know about, and the alternate configuration needs to be something that you at least know about with your Windows Server 2003 servers. Now you also need to be aware of certain ports that need to be available or open on your firewalls, especially so that you can allow network communications to take place. For example, I'll take a look at some port numbers here so that you can see which ports are available or which ports are necessary to do certain kinds of communication. And I'll also put this file up there on nuggetlab.com for you. For example, TCP 3389 is a port that you'll need to use. You can have either TCP ports or UDP ports. A TCP protocol is a connection-oriented protocol, which means that it does sequencing, it does things to make sure that the delivery is guaranteed and stuff like that. It verifies the delivery of the data. UDP, on the other hand, just is a best efforts protocol, and it's a what's called a connectionless service, and it just does a best efforts method. Well, anyway, with TCP port 3389, you use that for remote desktop protocol, and that's going to do things such as terminal services for your remote desktop, remote assistance, and this is how we can access another desktop remotely using this kind of a protocol. TCP 1723 is for point-to-point tunneling protocols for your VPNs. Another kind of VPN you can use is L2TP, and this is layer 2 tunneling protocol that uses UDP ports 500, 1701, and 4500. Then, of course, I think you're probably aware that TCP 80 is our HTTP protocol that we use on the internet. If you use secure transactions over HTTP, that's HTTPS, which uses both TCP and UDP 443. And then we also have TCP 20 and 21. 20 is the data over FTP, or the file transfer protocol, and then 21 is for control data. And then UDP 123 is the network time protocol, and that's how your domain controllers and all of the current Windows clients will synchronize with domain controllers. It's how they synchronize the correct time. And in a current Microsoft Windows network using UDP 123 and the network time protocol, you should get very close synchronization between all of your clients and all of your servers. TCP 445 and UDP 445 is used for Microsoft Directory Services, or for Active Directory. Now, another very useful utility regarding ports is the netstat command from a command line. And if I do a netstat-a, that shows me all things that are going on with netstat right now and with all the ports that I have on this local system. And we see that, for example, I have TCP port going on. What's a good example? Here's a good one. DC Nugget 1 is using 3389. What is it doing? Nothing. It's just listening for any connections that might come up on that port. So that's what it's doing right now with that. If I had an FTP server here, it would also show me DC Nugget 1, and then it would give me a colon 21 for port 21 for FTP connections and so forth. And it shows you, like you can see here, both TCP and UDP ports that are in action. And if it gives me a star, that means that it doesn't have a connection right now at all going on. Now, let me go ahead and establish a connection using remote desktop connection, for example, to my DC Nugget 2 server. And so now I've got a port 3389 connection going on. Let me also do an FTP connection to my FTP server, to .NET, which is just an anonymous connection real quick here. And now if I do netstat-a again, we'll see mostly the same stuff, but now we'll also see here that not only do I have port 3389 listening over here, I've also got an established connection, and if I can just see the forest for the tree, there it is. Now I've got DC Nugget 2 established over here on 3389. Notice also that once it establishes the connection, it uses a random port number, just 2080 in this case, a random port number to complete the connection. I also have an FTP connection established over here, and it again has a random port number on the other side, on this side, as it completes that connection. And you might also find this netstat variation useful, netstat, and then just the -a, which I already did, and then a -n, which shows you only the numerical item. Because if you just do a -a, you might have noticed in the previous interface, sometimes it'll actually just name the protocol, like FTP. It doesn't show you port 21, it just shows you FTP. Well, if you want to see the specific port number for some of those that it would have otherwise given you a name for, then you do a -n there, and it gives you the number. Then it shows you not even the name of the server, it just shows me the IP addresses here. And there's my 10.10.10.4, that's my .NET server, and it's using port 21 there, whereas before it said .NET and then FTP. Now I can see the actual specific port number, so that might be useful for you to know as well. Well, we're reaching the bottom of our junk drawer, and there are two more tools that we can pull out. One of those is traceroute. This is an old command that we've used in TCP/IP for years, and even in different operating systems. And what it does is it traces or troubleshoots the connection between two hosts. We'll normally use this on more elaborate networks, across WAN links, across internet connections, and that kind of thing, where we want to check out the health of our routers and make sure that it's passing through the routers in a reasonable fashion, a reasonable time fashion. The command is trace ERT or trace route here, and then you just enter in the host. It can be an IP address or it can be a fully qualified domain name, whatever you want, just anything that's reachable and resolvable. And it'll trace the route to that host. It identifies the IP address of that host, so I see that it's resolved it on a DNS server somewhere out there on the internet, and it goes over a maximum of 30 hops. Here it sees on our first hop, or our first router, and by the way, it goes from the nearest router to the most remote router closest to the destination. It started off at 9 milliseconds, 11 milliseconds, very fast connections. There's no issues there. Sometimes you will get one hop that does have a timeout. There might be certain routers along the way that are programmed to not be able to not respond to ICMP echo requests, because that's all this is. Traceroute sends out an ICMP echo request to the destination. And that's okay because we see that we're still pushing through here and we're getting okay. Now as I get close to the end here, I see I get 66.224.46.234. Well, now after that, I'm getting all these requests timed out. So what could that be? Well, if I just ping www.cbtnuggets.com, then I'll see that it's not responding to my ping packets. What is that going to tell me then? Well, I'm kind of connecting the dots here, and I'm just going to Control-C to cancel that right now. What that's telling me then is when it actually hits www.cbtnuggets.com, it's timing out because www.cbtnuggets.com is programmed to not respond to ICMP echo requests. And that's not an uncommon thing because a lot of web servers out there won't respond because they don't want to be subject to a denial of service attack where it'll receive a flurry of ICMP echo requests from a hacker, and it might be a distributed denial of service attack, in fact, where it's got zombies out there on the internet that unwittingly send out these ICMP echo requests to the host and then bring it down because it's got so many requests that it can't possibly respond to them all. Well, that's all that's happening here. And I mentioned a minute ago that I was connecting the dots there. You see the IP address that I alluded to. Well, that's very close to the IP address that we actually have for this host. So my guess here in this case is that once it goes past the ISP for cbtnuggets.com, then that's when we hit this web server and that's when it's not responding anymore. And in reality, it's probably a firewall or a router in front of that web server that's blocking or rejecting those ICMP requests. And then another thing I could do is to do a trace route to cbtnuggets.com again, and then this time a greater than symbol to a text file, and you can just name this whatever you want to. I just put a .txt extension on the end so it would automatically open up in Notepad, and then it would not put the output on the screen, it would put it in this file instead, and that way I can further manipulate it or look at it a little bit later on. Another thing that I do that with is also a command called pathping, and pathping, I'll just go ahead and get it started here. Pathping is very similar to traceroute, except it's a little bit more involved. This takes an exceptionally long period of time to run, and it's a lot more elaborate, and it will go ahead and identify more specifically problems that it's having with hosts that it will not be able to connect to, or rather with hops that it will not be able to make any connections to. Since that takes quite a long time, I'm going to cancel that for the time being. You can also run this, again, with the greater than symbol and then a text file. I've already done that offline here so that we have something to work with. So let's go ahead and open a pathping command to www.cbtnuggets.com. Now here I used the pathping command, and I sent it out also to a text file. So it's tracing it out again to cbtnuggets.com, and again we see the hops that it's using. But the difference between traceroute and pathping is that pathping is more thorough, and it will send out a whole series of packets from the source to the destination through each router. And because it's going to do that, it's going to be able to more closely identify the degree of packet loss that's going to be experienced at any given router. So for example, here it compares the amount of packets lost to the packets sent, and we didn't lose any, so we have 0% packet loss. That looks pretty good. And it shows you the round trip time, 11 milliseconds. Again, that's pretty good. And then the distance between two hops is the link, and that's what this is, this node, this link. Again, on that link, that segment between the routers, again, we lost 0 packets, so we have a 0% loss. And again, we're looking pretty good there. Now you can also see that the pathping command takes a little longer. For example, it took 275 seconds to calculate all of this because it continues to send data through this to see how it performs over a period of time between these routers and between these links. And again, this is what we'll use to determine where we're getting a slowdown. Here we lost, 2%, so still no big deal. If we were losing 60%, 80%, some other more alarming percentage, then we might be able to identify an ISP's router or an ISP's link that was having a problem, or one of our own WAN links that was potentially also having a problem. Alright, let me go ahead and just pull out another tool here. I think you're going to like this one a lot as well. It's found in Help and Support Center, and this one is under the Tools item down here in Help and Support Center, or HSC as we just call it for short sometimes. And then under Help and Support Center Tools, we look at Network Diagnostics, and you can set certain scanning options. So you can specify whether you want the information to be verbose, whether you want to check out, the mail service. I don't really have it running here, so that wouldn't matter to me, or the news service. None of this stuff would matter to me. So you can clear certain things or add certain things if they matter a little bit more to you. Anyway, then you scan the system, and it takes a little while to run. Then when it's done, it gives you a result of everything it was able to find. Now, once it's complete, for example, here we see that we get the information that we want. You can save it to a file if necessary as well, and that way you can analyze it a little bit better, because as soon as you close this window, this Help and Support Center, all this information goes away. So saving it to a file will make a permanent record for you. It gives you information about the system, and that's one thing I like about it. It gives you information not just about the networking and stuff like that, but also about the actual computer system itself, and it gives you a pretty self-explanatory information for most of this stuff. For example, somewhere up there it said daylight, whether or not you observe daylight savings time. I'm in Arizona, so we don't observe daylight savings time because when it's 120 degrees in the middle of the summer, we don't want to extend that by an additional hour at night. So that's one of the things that it shows us there. Information about the operating system, what country code you're in, all that kind of stuff. And then down here in terms of our current discussion with networking, for the network adapter, it shows me, for example, whether or not it's DHCP enabled, what DNS configuration it's got, all that kind of stuff, what its IP address is and the like, how its DNS servers are working, whether it was able to connect to the DNS server. You see that it just pings it to make sure that it is able to get a connection to that DNS server, which is real easy in this case because this local machine is also the DNS server. So anyway, this is really verbose information. I think you'll like what you see there. It's just a quick, easy way to get a lot of information. And there's also a command line utility which really gives you pretty much the same information just from a command line, netdiag. If you just run this, then it gives you pretty much the same information to a command line. And I pause for a moment to let it go ahead and run, and it just gives you the name of the system, what its DNS host name is. It's kind of interesting here. It says it's Windows 2000 server. Wow, we're really advanced here. Actually, it is Windows Server 2003 as designated by the build number over here. It tells you which hotfixes are installed. That's kind of handy to know if you want to know if you have a security hotfix that you need to apply, whether one's missing there or not. There are better ways to identify if you're missing security patches, but at least it gives you some rudimentary information there. And again, it tests your network card, tests all of the connections to the network card, the DNS servers, and all that kind of stuff. In this nugget, we took a look at various IP tools, and we started with the discussion of IP config, which you might have used in the past, but which has some new options that are very useful, especially in terms of looking at and clearing any cached DNS names. We also took a look at how to look at MAC addresses, and you can use ARP for that, for example. And you also might need to be able to clear the ARP cache, so we took a look at that also. Now, the repair button on your connection is kind of a shotgun blast that we took a look at, and it will fix many different things at once and prevent you from having to do a lot of manual troubleshooting. We also took a look at automatic private IP addressing, which is a handy way to at least stay with the TCP/IP stack loaded and at least get a temporary address while you're waiting for a DHCP server to become available if it's not available. Then we can also look at alternate configuration, and that's one thing that we saw that will give you a static IP address in absence of a DHCP server. We took a look at various ports that are very commonly used and that you probably should be aware of, and we took a look at other tools as well, such as Netstat, Traceroute, PathPing, and network diagnostics. I hope this has been informative for you, and I'd like to thank you for viewing.